1/4 plus 1/6, okay? Well, you could do the same thing. You could say, okay, I'm going to multiply by 6, and I'm going to multiply by 4, okay? And this
Okay.
becomes 6/24 plus 4/24, but is 24 really the LCM of 4 and 6? And the answer is no. The LCM, if you remember, you make a factor tree here. You say, okay, 2 goes into 4, 2 goes into 6, 3 goes into 3. So your LCM is actually 2 times 2 times 3, which is 12.
Okay.
And so the
Hold
point
on.
is,
Sorry, my grandpa's calling me. I'll be right
sure.
back.
Yep.
Yes. Sorry about that. Sorry about that. I can't hear you.
All right. So just making sure you're back here. Everything good, ready to go?
Yes.
Okay. So the point here is that while you can always multiply, problem is that, well, when you add the fractions now, you then typically have to reduce. Okay. So, you might think, oh, well, that's no big deal. I'll just reduce. Well, if you find the LCM, sometimes you don't have to reduce. Okay. This becomes 5/12 because you can divide both of them by 2. So you're the kind of math student that needs to consider these options. Okay. You need to say, okay, well, if I do 12 and 12, that means I'm really actually multiplying 4 by 3 and 6 by 2. Do you see that?
Yeah.
And so 3/12 plus 2/12 is 5/12.
Okay.
All right. Now, what does that mean? Well, it means that you have to decide. Okay. And really, when you're adding more than 2 fractions, you really want to go down the road of the LCM. Okay. And that's kind of the direction we were heading last time. So, if I give you fractions like 2 2/3 plus 3/4 plus 5/6, okay. The last thing you want to do here is multiply 3 times 4 times 6, 4 times 3 times 6, and 6 times 4 times 3. You really want to find the LCM of 3, 4, and 6. So could you do that for us, please?
Yep. Is it 3 times 2 times 2?
It's 12. And so that's your new denominator in all of these. So what I want you to do, and this is where you got to use your division or your multiplication. You got to say, okay, how do I go from 3 to 12? How do I go from 4 to 12? How do I go from 6 to 12? Like, what do you multiply by? Because it's different for each one. Okay, is that clear?
Yeah.
All right, so go ahead and multiply by whatever and tell me what goes in each of these positions.
Okay, so for the first one, it's 8. For the second one, it's 9. And for the third one, it's 10.
Excellent. Okay, now I want you to add the numerators.
They got 27/12.
Okay, and then I think we talked about this last time. Well, so again, like not always. So even though you found the LCM, you still can reduce this. It's also an improper fraction, which means you can write it as a mixed number.
Mhm.
All right, which means that you have to do maybe both. And I like to reduce first before writing it as a mixed number, but you may not
Okay.
be super comfortable doing that yet.
Yeah.
So it's kind of up to you.
I just did the mixed number.
Okay, so that mixed number you're going to have to reduce though. Like you don't, it's like you don't get out of it. You still have to do that part of it.
Okay. So would it be 2 1/4?
Okay, so you got 2 1/4. Yes, that is correct.
Okay.
Okay, very good. All right. Okay, so I think let me go check the notes because I want to do some subtraction problems, and I don't remember if we talked about that. Okay, let me just ask you something. What is 6 minus 9? This is just helping me to know if we can proceed forward with some subtraction stuff.
Would it be -3?
Yes. Okay, very good. So I've been focusing on adding fractions, but really we can do a lot of things. We can do 5/16 minus 3/4 plus 1/8. Okay.
Mhm.
And the only difference here is that instead of adding the numbers in the numerator, you're going to have to subtract, something. Okay. So what I want you to
Okay.
first do is find the LCM of 16, 4, and 8, please.
Okay. Is the LCM 16?
Yes, perfect. So sometimes it actually is the number. Okay. So you want to write the three fractions, the new fractions.
Okay. So I did not hear what you just said.
I said you're going to want to go ahead and write the new fractions all over
Oh.
16.
Okay. Okay, so for the first one, it's 5/16. For the second one, it's 12/16. For the third one, it's 2/16.
Okay, so the way this works now is you write the numbers in the numerator 5 minus 12 plus 2 all over 16. And then you have to determine what that is.
Okay, I got -8/16.
Try that one more time. So like what is 5 minus 12?
6, -6.
It's -7. And
Oh,
there's a mistake.
okay. So would it be -9/16?
Well, so yeah, this is -7 plus 2. That's where I wasn't sure how much of this you've actually done. This actually is -5
Oh,
over
yeah, I've
16.
done this. I did not do this a lot. We were doing this
Okay,
at like the end of the year,
yeah,
but yeah.
got it. Yeah, and I just want to be careful here with that. So, okay. I won't throw too many negatives at you. That can be addressed at another time. So let's go back to mixed numbers.
Yeah.
Okay, let's go back to, and this is a nice example. So here are two mixed numbers that you're going to add together.
Okay.
So go ahead and try working this out. I just want to, just whatever, or if you don't know at all, that's okay too. I don't want to jump in until I know that you need some help on something like this.
Okay. I got 7 3/5.
How did you do that? Did you add the whole numbers together?
No,
What did you
I
do?
did 6 times 5 plus 2, and then I put that over
I see.
5,
I see.
and then I
Okay,
did
yeah,
1/5.
so that does work. The way you're doing it does work. You could see there that 6 plus 1 is 7, and
Mhm.
2/5 plus 1/5 is 3/5.
Oh yeah, that's quicker.
Well, it depends on the problem. Okay.
Okay.
All right. So just keep that in mind. Like it's not a guarantee here that it's going to always work. Let me throw another one at you just to see how 8 and 7/8 plus 3 and 3/8. And that doesn't matter to me how you do it. I just want to kind of gauge how you work through this before we work on some problems.
I got 12 and 1/4.
Okay, so tell me how you did that, because that is the correct answer, but I'd like to know what
Okay.
your steps were.
So this time I did 8 plus 3, which is 11. And then I did 7 plus 3, which was 10 over 8. And then I divided that. And then I got 1 and 2/8. And I reduced the 2/8 to 1/4. And then I added that to 11.
Good. Good, that's perfect. That's really good. Really good. Okay, that's good. So now we're gonna spend some time talking about subtraction, okay, of these things. So let's say for example, and it's very similar until you get the borrowing scenario. So let's look at this first example together. So 8 and 5/7 minus 3 and 1/7. So what this really is you take the 8 and you subtract the 3. That's 5. Then you take the 5/7 and subtract the 1/7, which is 4/7, and that's your answer.
Oh, okay.
Okay, now that's the clean, nice one, no big deal. Let me do another one for you, and then we'll talk about potential issues that you might face. So
Okay.
here's another one for you to look at. 7 3/4 minus 3. So you take that 7 and you subtract the 3, which is 4. Then you take the 3/4 and you subtract the 1/8. You have to find a common denominator. 6/8 minus 1/8 is 5/8.
Okay.
And so it's 4 and 5/8. Okay, so sometimes you have to borrow, you have to.
Okay.
So that's the easy stuff. So let me give you a couple of problems here to try. 6 and 2/3 minus 4 and 1/5. Just go ahead and try this one for me, please.
Okay. Okay. Hold on. So I subtracted 6 and 4 and got 2.
Okay.
and then I subtracted 2/3 and 1/5, but I had to like get a common denominator, so I got 15 for the common denominator. And then for the first one, I got 10 over 15, and for the other one, I got 3 over 15. And that's where I am right now.
Okay, yeah, keep
So-
going. You're doing great.
Okay, I got 2 and 7 over 15.
That is correct. Okay. All right, so these are the nice ones. Here is where we run into problems. So I'm going to do a couple of examples for you, and then actually let me start with an easier one. Let's say it's 4 and 2/9 minus 1 and 7/9. Okay,
Okay.
so if you
Okay.
take 4 and you subtract 1, you get 3. No
3.
big deal. But 2/9 minus 7/9, well, this is potentially bad. Okay.
Yeah.
So whenever you have the situation where it ends up being negative like this, it's -5 over 9. The way to proceed is actually to restart the problem. That's what I'm going to do
Oh.
here. And you actually want to borrow from the 4.
Oh
So
yeah,
you
I
treat
think I remember doing this in the
yeah,
beginning
you
of the
treat
year.
this 4 as 3 plus 1. And so now it's not 2/9, it's 1 and 2/9.
Oh, okay.
Okay, so now you still do the 3 minus 1, that's 2. But now this 1 and 2/9 minus 1 and 7/9. I'm sorry, not 1 and 7/9.
Okay.
It's the 7/9. This is where you do want to make it an improper fraction. So it becomes 11 over 9 minus 7 over 9, which is 4 over 9.
I have a question.
Yeah.
So when you have like a mixed number like 1 and 2/9, how do you
Yeah.
get it to like, I meant like a mixed number like 11 over 9?
Well, you told me this earlier. You took the 9, you multiplied it by the 1, and you add the 2.
Oh yeah. Oh yeah. I never did it that way. Okay. I only used to do that. Well, I only do that when there's 2 of them, but I never did it like that. But now I know.
Yeah, I mean, hopefully you see why you do that. It's because you really want it to be larger. If this fraction is smaller than this fraction, then you have to borrow
Okay.
from somewhere.
Okay.
Is that okay?
Yes.
Great. Okay, so here's one for you to try. 9 and 3/7 minus 6 and 5/7. Can I give that a try, please?
I got 2 and 5/7.
All right. That sounds correct. You said 2 and 5/7.
Yes.
Yes, that's correct. Good. Great. So the next types of problems are where you have to decide whether the fractions are smaller. Like sometimes you don't know just by looking at them. So for example, like let's say it was like 5 over 8 and I don't know, let's go don't make this too crazy. 13 over 20. Like, do you
Okay.
know which one is larger here? or how to figure out which one is larger?
Is it 5/8?
Well, the question is how to figure it out without,
Oh,
and really it's to do the whole LCM thing.
oh, okay. So, okay. Let me just do that really quickly. Okay, so would the denominator be 40? Mm. So you add, wait. Okay, so then the 13 would be 20 times 2 and 13 times 2,
So
which would be
26.
6. Okay, and then 5, 5. So 25 times, or yeah, 25 over 40.
See how close they are?
Yeah.
And so it's actually that it's this way.
Oh, okay. Yeah, I
Right.
did not know how to do that.
So that's how you decide. You find an LCM and so on. Is your sister ready now? There was some that she
Yes,
might be
let me go
coming in
get
a little.
her.
Oh, okay, we can do one more problem if you want to.
Okay.
Let me have you do one more here, just to kind of solidify what we've been doing, and then we'll switch. Okay, so give this one a try, please.
So 3. It got 2 and 5 over 12.
Okay, that's correct. All right,
Okay.
yeah. If you want to let your sister know I'm ready for her, I'll
Okay, let me go get her. Hi.
Hey, is it Julia?
Yes,
How was soccer?
it was good.
That's great. It's so hot in the mornings, you can't even believe you
Yeah,
guys
I'm
are doing
sunburnt
stuff.
now.
Boy, well, I'll try not to add to the misery of this. Last time we were doing some order of operations, and I think it's because it's been a little while since we've done a lesson. I always kind of like to go back and redo a lot of the stuff we did in the
Yeah,
previous one
yeah.
until we kind of get it solidified, but it goes pretty quick. Do you have your
Mhm.
notebook out, your whiteboard out? Are you all
Yes.
ready to go? Excellent.
Yeah.
Okay. So kind of like, if you recall, you do multiplication and division before addition and subtraction.
Yes.
And we started talking about, positives and negatives. So, quick review, positive times a positive. Well, that's obviously a positive. Okay.
Yes.
A negative times a negative is a negative, but a positive times a negative or a negative times a positive, well, those both become negative. Okay. And same thing with division. Like if it's a positive divided by a positive or a negative divided by a negative. Sorry, this is that's really bad. I'm sorry. If they're same sign, it's always positive. If they're opposite sign, it's always negative.
Okay.
Okay, so it's just a quick review. It's like, for example, if I give you -4 times -3 plus -2 times 3, there's a lot of space in there. You're supposed to say, okay, I'm going to multiply before I add. Okay, so you
Mhm.
got to be able to multiply these two together. These two
Okay.
together. So could you try that for us, please?
Yeah. You want me to do the whole thing?
As far as you want to go. If you feel confident, just keep going.
Okay. Um, is -2 times 3, is the answer a negative or a positive?
Let's
I'm
go look at our
confused.
rules here. If they're opposite in sign, one negative and one positive, the answer is
A
negative.
negative.
Yeah.
Okay. Um, okay, -18.
Is that your final answer?
Yeah,
Okay, do you get for -4 times -3?
-12.
Okay, but they're both the same. They're both negative. So what does the answer become?
Oh, positive. I'm so
Positive 12.
confused because like sometimes like don't you like have to like keep the sign of the bigger number, or if they're the same, you keep that sign?
So that's adding and subtracting.
Oh,
Okay, these are the
okay.
rules for multiplication and division.
Okay.
So we'll get here. So it's 12 plus -6.
Okay. So that would be -18, right?
Nope, they're opposite in sign. One's positive, one's negative. So we'll
So it
review
would
that as
be
well. The
what?
the
But
the
if
one
it's
that's
okay, so it's opposite, then it would be negative.
the one that's further from zero tells you the sign, which is further from zero, positive 12 or
12,
-6. So the
12.
answer is positive, and then you take the larger and subtract the smaller.
Okay. So, oh, okay. So, 6.
It's 6, yeah, positive 6. Okay, let's try another one here.
Okay.
Go 5 plus -4 times -5 minus 10. Okay,
Mm-hmm. Okay.
so what do you do first? Addition,
Multiplication.
multiplication. Okay, so you got to multiply these two numbers together.
So 20.
Okay, so it's good to rewrite it each time.
Yeah.
Okay, and then you do addition and subtraction, just like multiplication and division,
Yeah.
left to right.
15.
Is 15. Good. Okay. Go back to making a little bit more difficult problem here. Let's go -8 times 2
Okay.
plus 3 times -4 minus
Okay.
1.
Okay.
Give this a try, please.
Okay. Oh. You take the sign from whatever's closest to the 0 or farthest.
I'm not sure what you're referring to, so yeah, why don't you give me what you've done first? And then we'll get to,
So first I did -8 times 2, and I got -16.
okay,
And then I did
plus,
+3 times -4 minus 1. So I reset it up, and then
okay,
I went back and I did -16 plus 12 minus 1.
yeah, but you have to multiply, right? So what is 3 times
Yeah,
-4?
12.
Nope, try again.
Oh. Oh, the negative of 1.
So it's -12,
Oh.
right?
Oh,
Positive and a negative.
yeah.
So somehow, and I know it's hard on the fly here, but somehow you have to get these rules down. You know, when you
Yeah.
go to soccer, you guys do drills, you run cones, you know, all of that is so that when you get into a game or something happens, you just do it without really thinking about it. Same thing
Yeah.
here. We want you to be able to quickly multiply these numbers together. And
Okay. So, okay. And then -16 plus -12. That'd be, would that be a positive since it's the same sign?
so when it's same sign, you keep the sign,
Oh.
and then you add the
Oh,
numbers. You add the
okay.
numbers without the signs.
I was confusing myself. Okay. So then that would be 28, -28,
Okay,
and then minus
-28
1,
minus 1.
and
Again,
that would
they're
be,
same sign.
so that'd be 29, -29.
Yes. Yep.
Okay.
Okay. We're making some progress here. Let me give you a new problem to try. -6 plus -3 times -2 minus -4 times -1. Okay. Now
Okay.
we did talk a little bit about when you need parentheses, and you actually can just treat this like it is the multiplication, and same thing
Okay.
over here.
So why did
But
you add parentheses?
just to show you another way that these problems could look, because I don't
Okay.
know how they're going to be presented to you. Um,
Okay. So first multiplication, so -3 times -2, and that would be -9.
yeah, so see how far you can work this.
Okay. Minus. Oh, that's times. Mm, -19.
-19, that's your final answer.
Mm-hmm.
Okay, so -6 plus, what did you write for -3 times -2?
-9.
How did you come up with that?
I multiplied -3, negative. Oh, it's 6. -6.
+6. Why is it +6? What do the signs tell you about that?
They're the same signs.
Okay,
So I'm
so that's
confused about that whole like keeping the sign, but then,
there's rules for multiplication, and then there's rules for addition and subtraction.
oh, I didn't know that was, oh, okay.
So
Okay, I didn't see.
you're mixing the rules. I mean, it's like, you know, going
Yeah.
from
So the first one is multiplication.
No, these are both for multiplication and division.
Okay.
Multiplication and division.
Okay.
Addition and subtraction we covered previously. We can do that again, and maybe we should. I'm trying really just to emphasize on the addition, multiplication, division. So like
Okay.
-3 times -2 is 6. What is -4 times -1?
Negative 4.
Again, they're both negative. Like, did you write these rules down somewhere? Like, you need
No.
them down where you can.
Okay.
You got to write these down somewhere where you can look at them, because, or I can keep scrolling every time, but that's going to get difficult. You have to just be able to look at these.
Okay. And then okay, I'm done.
Okay. Okay, so again, like when you look at this, what you're supposed to say is that they are the same sign. They're both negative or both negative. Okay, and you look at your cheat sheet, reference sheet, and you say, okay, they're both negative, which means the answer is positive. So what is
Yeah.
-4 times -1?
Positive 4.
Positive 4. Good. Okay, and then you now we're to addition and subtraction. So let's talk about the rules for addition and subtraction.
Okay.
If they are same sign, okay, the first thing you do is you keep the sign.
Yeah.
Then you add them without the side.
Okay.
Okay. If they're opposite in sign, this is the harder one. This is the one we see more often. I mean, that's this first one, -6 plus 6. First thing you do is you determine the sign. You determine the sign by determining which one is further from 0.
Yeah.
Okay. Then you subtract, you take the larger minus the smaller without the sign.
Okay.
Okay, so again, we did a bunch of examples. I mean, I don't want to use up our time here for that, but we could if we need to. But like these rules, like these are just words. You need to like have some examples down, or we can do some, but you got to know these rules as well, so that when you get to a
Yeah.
line like this, you're like, oh, I know how to proceed. Now, -6 plus 6. The problem with this one is they are opposite in sign, and they're both the same distance from 0. So the answer is actually 0.
Oh, okay.
That does happen. What about 0 minus 4?
That would be 4. -4 still.
-4 still. 0 doesn't affect anything. Okay, you ready to try another one here?
Yeah.
Okay. So let's say, let's do this. -5 times 2 plus -3 times 3 minus -4 times -2.
Okay. -16.
Is that your final answer?
Mm-hmm.
Okay, let's go through it in pieces here. What is -5 times 2?
-10.
Good. How about -3 times 3?
0.
But you're multiplying. You're multiplying, not adding.
Oh, 9.
Nope.
-9.
-9. Okay. Try again. Try the next one here. Sorry. -4 times -2.
-8.
Okay, but they're same sign.
So, okay, 8.
8. Okay. So there's still some disconnect. Like there's still some
Mhm.
disconnect where like you're mixing the rules or you're trying to remember the
Yeah.
like one of the things that helps me sometimes is just talking it out loud. Now, if you don't want me to listen to you talking out loud, you can mute, yourself. That's fine. You somehow need to like get this down. Like we cannot proceed if we're not able to do this type of problems. Meaning
Yeah.
like you got to be really fast on this, and you can do it. There's nothing. It's not rocket science here. I mean, I would argue this is easier than kicking a soccer ball. I mean, I know that that's pretty easy, but to get the soccer ball to go exactly where you want to go is pretty tough sometimes. There are
Mhm.
defined rules for this. There's nothing weird.
Okay.
So now let's try this. -10 plus -9. What does that become?
+19.
Okay, so when you're adding and subtracting, these are same sign. They're both negative.
Yeah, so then wouldn't that turn into a positive?
No, you
Oh,
got to go back to your rules here. If they're same sign, you keep the sign.
okay.
Okay, and then you
Yeah.
add them without the sign. So you treat it as 10 and 9. You add 10 to 9. What
Okay.
does that become?
19.
19. Good. -8. Okay. So again, these are same sign. I know it's subtraction, but the subtraction really means it's negative. So it's a -19 and -8.
-11.
You keep it and then you add the numbers without the sign.
-11.
You add the numbers without the signs. You got to add them. Adding them gets bigger.
Okay. 27.
27. Yeah. Okay. It sounds like we should do some quick addition and subtraction practice. Okay.
Yeah.
Okay. So same sign. Here are some same sign examples. And
Okay.
you're going to think these are ridiculous because they are. What is 3 plus 4?
7.
7. Now, here's why it's 7. They're both positive. So it's positive, and then you add the numbers without the sign. You say it's 3 plus 4,
Yeah.
which is 7. Okay,
Mhm.
now, what about -5 plus -2? Okay, are these same sign?
Yeah.
Yes. So the answer is negative, and then you add the numbers without the sign. You say, okay, it's really a 5 and a 2. What is 5 plus 2?
7.
7. That's -7. Now, the other form this could appear in is -3 minus 8. Okay. These
Okay.
are still same sign. I know maybe you think that 8 is positive, but with this minus here, the subtraction here, it really means it goes with the 8. So it's -3 minus 8. They're both negative. So you first keep the sign
So negative.
negative, and then you add the numbers without the signs.
11.
Right. Okay. So these are your same sign examples. These are the ones that should be trivial, meaning like you get them, no big deal. The opposites in sign, I know that is challenging. I mean, it's because there's more rules. So let's take again a really simple example. 9 minus 6. Are these opposite in sign? Is one positive and one negative?
Yeah.
Yes. Okay. So to determine the sign, you have to see which one is further from 0. Which is
9.
further from 0? 9 or -6? Yeah. Okay. So that tells you the answer is positive. And then you take the larger and subtract the smaller without the sign, without the
Okay.
signs. So you
Is
just say, oh,
this
it's 9.
is this still on addition and subtraction?
Yes.
Okay.
There's 2 cases for addition and subtraction. Same sign, opposite sign. So now let's do a more realistic one. -8 plus 4. Okay. Are these opposite in sign? Is one negative and one positive?
Yes.
Yes. Okay. Which means that you have to determine the sign. Which is further from 0, -8 or +4?
-8. So
So the answer is negative. Then you treat the numbers without the signs. Like you look at it as an 8 and a 4. You have to say it's an 8 and a 4. You take the larger, which is larger, 8 or 4?
8.
8, and you subtract the 4. What does that become?
4.
4 with the negative.
Mm-hmm. Okay.
All right. So like you will eventually just go to this step here. All right. Here's another one you might see. 10 minus 13. Are these opposite in sign?
Yes.
Yes. Which one's positive and which one's negative?
10 is positive, 13 is negative.
Right. So you have to first determine the sign of the answer. Is it negative or positive?
Negative.
Negative. Then you treat the numbers as 10 and 13, and you say, okay, well, I'm going to take the larger and subtract the smaller.
So -3.
There's your answer. All right. So we are out of time here for today. When you do your review, I'd recommend kind of working it from the end there, maybe.